Alright, so today we're going to talk a little bit about polynomials and how polynomials are kind of just introduced as general. So the first thing we really need to know about polynomials is going to be what a polynomial is. So a polynomial is going to be any kind of term anything that has multiple terms. So if you took, like, say, x squared plus 5x plus 3. In this one we have three different terms, x squared, 5x, and 3. So since this has three terms, this would be what we call a polynomial. Now, a polynomial is when we have any amount of terms. We can break these down into smaller bits, such as monomial, or binomial, or even trinomials. Now, each one of these is going to basically give us a little information based off of these root words. So mono is going to represent 1. So if we have monomial, that's going to be a polynomial with one term. So like 3x squared. That would be an example of a monomial, because it only has one term. A binomial would be something with two terms. X plus 1. That has two terms. So two terms would be a binomial. Three terms would be a trinomial. So like our example up above, x squared plus 5x plus 3 would be an example of a trinomial. All of these are what we know is to be polynomials. And really a polynomial or polynomials can represent any number of terms. If we had 4 terms, 5 terms, 6 terms, those are all represented as what we call polynomials. The only ones that have specific names are the monomial, binomial, and trinomial. Now, for it to be a polynomial has to have positive exponents that are not fractions and do not have variables. It's actually easier to look at what a polynomial is not. So, for something to be not a polynomial, we got to look at how the exponents stand. So let's say we had something where we had x to the 1/2 power plus 3x minus 1. This is not a polynomial because of the 1/2 exponent. That is a case where the exponent is a fraction. If the exponent is a fraction, then we cannot have a polynomial. In another example, what if we had, say, x to the -3rd power plus 2x minus 1? Then once again, this is not a polynomial because of the negative exponent. So if your exponent is a negative, then that means that this cannot be a polynomial. And then the last example is whenever we have a polynomial that has a variable. So something like 3 to the x power plus 2x plus 1. This is an example of not a polynomial because of the variable that is labeled as the exponent. So here a variable causes this not to be a polynomial. So if you run into any of these three traits, then that means that it's not a polynomial. If it ends up where none of these three exist, then that is a case where it is a polynomial. And like I said, usually polynomials are going to be positive numbers greater than 1, or positive numbers greater than 0. Okay? 1 is included in that. So anything that's positive number greater than 0 is usually going to be your polynomials, as long as they're not fractions, as long as they're not negative, and as long as they don't have variables included. Now, another concept we're going to talk about is degrees and leading coefficients. Now, these two things, I'm going to abbreviate them as D, and I'm going to abbreviate them as LC. But it's really easy to know what the degrees and leading coefficient is. It's actually probably one of the easiest things we'll learn all year. So the degree of a polynomial, first I'm going to start by taking my polynomial and writing it in order by its exponents from greatest to least. So an example of this would be, say we have 3x plus x squared minus 1. This obviously is not written in order from greatest to least by the exponents. So the first thing we need to do is we need to rewrite the order. So we're going to write this first off with the x squared coming first, since it's the highest exponent, followed by the 3x, since it's to the first power, x is to the first power there. And then we're going to write the last one, the minus 1, since it does not have any variables with it. Okay? Constants always come at the end. So once we have this in order from greatest to least by exponent, we can determine the degree by looking at the highest exponent. So here the highest exponent should be the first one, which is 2. So if the 2 is the highest exponent, then the degrees is going to be 2. The leading coefficient is going to be the number that is in front of the highest exponent. So the great part about this is we've already identified the highest exponent as 2. So the number that comes in the front of the x, there's no number. So that means that it has to be understood to be a 1. So here the leading coefficient would actually be the number 1. So it's really easy to determine the degrees in the leading coefficient in a polynomial. The only time this really gets tricky is if you have multiple exponents in one term. Let's say we had the problem 3x squared plus 4x squared y squared. Now this one becomes a little tricky because the exponents are kind of all 2's. So which one has the higher degree? So to determine the degree, all we're going to do is look at the exponents, and if there's more than one exponent in a term, we're going to add those two together. So in the first term, we have 3x squared. There's only one exponent, so we know the degree there is 2. If we look at the next term, however, we see that 4x squared y squared actually has 2 exponents. So we're going to take those 2 exponents and just simply add them together. So what is 2 plus 2? 4. So here the higher degree would be the greater number. So in this case, the higher degree would be 4. So we're going to use 4 as our degree. So in our second example, 4 would be our answer in that problem. Now, to determine the leading coefficient, look at the highest degree, and then the number in front would be the leading coefficient. So here the highest degree was 4. So if we look in front of that, the number that's located in front of the xy, or x squared y squared, would be the number 4. So it actually turns out here that the leading coefficient is also 4. So with degrees and leading coefficients, it's really easy. Degrees is going to be whenever you're looking at your highest exponent, and then the leading coefficient is going to be the number or the coefficient that appears out in front of the highest exponent. If you have any questions about this, I know this could be a confusing topic for some guys, or some of you guys, but if you have any questions about it, please email me. Like I said, I can also talk about this in class if you have a question about it, but really kind of a simple topic, okay? If you have a question, it's not much too hard to clear it up. All right, the last thing we're going to talk about is going to be when we have combining like terms. The concept of combining like terms is something that's going to carry into our next lesson. So let's look at this real quick and just make sure we can understand how to do that. So let's take the example 3x plus 5x squared minus 8x minus 3x squared plus 2. If we had this problem and we needed to combine like terms, the concept of combining like terms is actually a very simple one. To combine like terms, we're going to take and combine the coefficients that have the same variable and exponent. So when we look at this, let's start with our first one, which is 3x. So 3x only has an x to the first power written behind the 3. So we want to find another number that has an x to the first power as well. Now you can probably go ahead and identify which one that is, and that's going to be our negative 8x. Notice how the two x's both have the same power, which is 1. So when we combine those, we just add the numbers that are in front. So what is 3 plus negative 8? Negative 5x is correct. Next, we'll look at our x squared. So we have positive 5x squared. So when we look at the numbers there, 5x squared, we need another x squared. So can you find the x squared? Yes. The other is negative 3x squared. So when we combine those two, just add them together. Or in this case, subtract. What's 5 minus 3? If you said 2x squared, you are correct. And then the last number, notice how this number has nothing to combine with. There's no other just plain numbers. So since there's no other plain numbers, we just simply write that number down on the end. So that will be plus 2. Now, we can't stop here because these are not in order from greatest to least exponent. So what we got to do here is we've got to start with the highest exponent, which would be 2x squared. Then we would take and write it by the next one, which would be the variable, which is negative 5x. And then the last one would be the number without a variable, which is plus 2. That would get this into its simplest form. Forgot my square. All right, so when you write this out, you'll notice that each one of these have a different variable. So we have x squareds, we have x's, and we have just numbers. And then we know that we can't combine this any further, therefore that is our simplest form. All right, so basically that's our lesson for this part today. If you have any other questions, let me know. We can go over it in class if you need help, or if you just need to email me and clear something up, that's fine. Feel free to email me as well. But like I said, take advantage of this. If you need to rewatch the video, go ahead and rewatch the video. But pretty much, so this is a very basic, very simple start to intro of polynomials. Next, we're going to talk a little bit about how to add and subtract those polynomials. So if you have any questions regarding that, we'll talk about that in the next lesson. Thank you.